So let's see. So this problem appeared in JEE Advanced 2019 paper 1. So let's see what it is. So what it says over here is that we have a set S, right? So this set S is the set of those complex numbers such that mod of z minus 2 plus iota is greater than or equal to root 5. So one thing is that when you read this problem, you can immediately recognize that this problem has a geometric interpretation, because I can read it as z minus 2 minus iota, this distance is greater than or equal to root 5. So you can see the set of points whose distance is larger than a fixed radius, and it will represent the exterior of a circle. So I'll just show it geometrically. The complex number z0 is the one which maximizes the value of 1 over mod z minus 1. So 1 over mod z0 minus 1 is the maximum of the set 1 over mod z minus 1. Then what is the principal argument of 4 minus z0 conjugate over z0 minus z0 conjugate plus 2 iota? Okay, so let's first try to understand what the set is. So the set S is the set of those complex numbers such that mod of z minus 2 minus iota is greater than or equal to root 5. So z minus 2 minus iota represents the distance of this point z from the point 2 minus iota. So here we have real axis and we have imaginary axis, and here is where the point 2 minus iota lies. So there is going to be a set of points whose distance with respect to z2 minus iota is larger than root 5. So basically if the distance equals root 5, then we get a boundary of a circle. But if it is larger than root 5, then it will represent the points which are exterior to a circle. So here we can check that actually origin also lies on the circular boundary, because distance between origin and 2 minus 1 is exactly root 5. So here we now have something like a circle, and this origin actually lies on the circle. The radius of the circle is root 5, and the points which are at a distance root 5 away from it are the points which are exterior to the circle, and circle is also included, right, because you have greater than or equal to root 5. So circle and the points exterior to the circle, these points are the ones which belong to the set S. Okay. Now we have to find that z0 which maximizes the value of 1 over mod z0 minus 1. So here basically we need to maximize 1 over mod z minus 1 such that z belongs to the above set S. Okay. Now if you want to maximize 1 over x, it's equivalent to minimizing x, right? So basically modulus is actually a positive number. So so lower the value of mod z minus 1 is, lower positive value it is, the larger is 1 over mod z minus 1. So that's what is happening here. And so we have to find that z0 who is now such that mod z minus 1 is minimized. Now again this has a geometric interpretation, because I can take this point which represents the complex number 1. So this is 1, 0 on 2D plane, and I now need to find a point on the set such that its distance from 1, 0 is the smallest. So first of all you can actually see is that the point whose distance is smallest from 1, 0 is going to be the one which actually lies on the circle rather than outside the circle. The reason is as follows, that suppose if there is some point which lies outside the circle, and if I connect it with this point 1, 0, then it will intersect the circle at some point, and this point of intersection will have a smaller distance to 1, 0, right, because it directly lies on the line and in between the 2 points. So that distance is going to be lesser. So basically if I have some point q which lies outside, I can join q to 1, 0, and I'll get some point p on the boundary. Now distance between p and 1, 0 is lesser than distance between q and 1, 0. So it has to be lying on the circle. Now which is the point on the circle which minimizes this distance? So just think for a moment yourself and see whether you can figure it out geometrically. You can maybe pause the video and maybe discuss it in comments also. Okay, so I hope you would have figured out that this point is the one which actually, suppose if I join this point 1, 0 to 2 minus iota, then the point at which intersects the circle is going to be the one which minimizes the distance. Why is it so? Because if I join the point 1, 0 to 2 minus iota, let's say this distance is d, then the distance between the point on the boundary which directly is obtained by connecting it to the line through 2 minus iota and 1. So this point, suppose if it is p, then this distance is going to be r minus t, where r is the radius of the circle, which is root 5. Now for any other point on the circle, right, for any other point on the circle, what we are going to have is that, suppose if there is some other point p prime on the circle, and let's say I have this point which is 1 comma 0, and I have this point which is 2 minus iota, then basically since it lies on the circle, this distance is going to be root 5, which is my radius, and let's say that distance between 1 comma 0 and 2 minus iota is d. Then by triangular inequality we have that this the line joining p prime to 1 comma 0, this distance must be greater than equal to r minus d, right? And at p, the value of r minus d is exactly achieved. So basically, to minimize the distance, what I can do is that I can draw a line from 2 minus iota to 1 comma 0. The point at which it intersects the circle is the one which minimizes the value of mod z minus 1. Okay. And how do I now find the point at which it intersects the circle? So basically the thing is that, so this distance, okay, so basically the idea is this, that so basically the idea is this, that we can actually find the phase and the distance of the point with respect to 2 minus iota. So first of all, any point on the circle can be represented as 2 minus iota plus root 5 times e to the power iota theta, okay, where theta is the relative angle of the line joining 2 minus iota to p. Now the line joining 2 minus iota to p actually passes through 1 comma 0, and we can check that the angle which this line makes with x-axis, we can actually find out that angle. So suppose if I have this point 2 minus iota and I have this point 1 comma 0, so basically what we can check is that we can actually find this sort of angle, and you can see that this is going to be, this height is 1 and this distance is also 1, so this theta is going to be pi over 4 over here. So let me call it theta prime, and the value of theta which it makes with positive x-axis is going to be thrice pi by 4. So here essentially with respect to 2 minus iota, the value is going to be, the distance of this point is going to be root 5, and the angle which this line makes is going to be precisely 3 pi by 4. So overall this point can be represented as 2 minus iota plus root 5 times e to the power iota 3 pi over 4, right? And now I can actually compute this value. So this is going to be nothing but cosine 3 pi by 4 plus iota sine 3 pi by 4. And so cosine 3 pi by 4 is going to be minus 1 over root 2 plus iota times sine 3 pi by 4, which is going to be plus 1 over root 2. And this point is then going to be 2 minus square root of 5 by 2 plus iota times minus 1 plus square root of 5 by 2. And this is going to be my point z0. Okay, so let's understand what we did over here again. So what we did was that if we look at the point relative to 2 minus iota, we know that it's root 5 distance away, and it makes an angle of 3 pi by 4 with positive x-axis. So with respect to 2 minus iota, the point P is of the form root 5 times e to the power iota 3 pi by 4. And if I add 2 minus iota to it, I'll get the absolute coordinates. And we see that those coordinates, I have obtained them as follows. Now let's look at the expression which we want to find. So we want to find the principal argument of 4 minus z0 bar over z0 minus z0 bar plus 2 iota. So let's see what it is. So this is 4 minus z0 bar over 2 iota plus z0 minus z0 bar. Okay, so this is going to be 4 minus twice the real part of z over twice iota plus twice iota the imaginary part of z0, right? So here this is my z0, and actually I can just compute this value. So 4 minus twice, so you can actually check that the numerator and denominator, so numerator is purely real, denominator is purely imaginary. So we are going to have a phase of either plus pi by 2 or minus pi by 2, and both of these are options here. But in order to determine which it is, we actually need to check whether it's iota times some positive value or negative value. So let's see. So the real part of z0 which we have computed is going to be 2 minus square root 5 by 2, and in the denominator we have the imaginary part over here, which is going to be minus 1 plus square root of 5 over 2. Okay, and so this I can check. So 4 minus 4, this gets cancelled, and overall in numerator I have twice of square root 5 by 2, and in the denominator this 2 iota and minus 2 iota will get cancelled, and I have 2 iota times square root of 5 by 2. So overall it's going to be like 1 over iota, which is minus iota, right? So the phase is going to be minus pi by 2, because with respect to positive x-axis, this point minus iota makes an angle of pi by 2 clockwise, and we know that clockwise angles are negative. So here we select the answer minus pi over 2, which is the correct answer here.